Good morning, ladies and gentlemen. Welcome back. It's Mr. Chen here, and we're going to talk about trigonometry, our first lesson from the package. From example 1, here we go. Again, trigonometry is the branch of mathematics that deals with triangle measurements, not all of them. But to help everyone out, even though our triangle is given to us, I'm going to redraw it. I actually don't like how it's drawn, so this might not be exactly the same. I like putting my drawings always like this. And the first thing, even though it's not noted here, hopefully some of you are observing in the class, is that the vertices of the triangle are capital letters. So this is angle A, angle C, and angle B. And the sides that correspond to the opposite angles are lowercase letters. So angle A and its opposite is side A. Angle C, its opposite is lowercase c. Angle B, opposite is lowercase b. This is always true for all triangles. So even if you don't have a right angle triangle, you should still be able to do the corresponding angles and sides. Hopefully you learned that in grade 10 and in grade 9. Also, as a recap, there are actually what's called trigonometric ratios, operations of the sides with respect to their angles. And this is what trigonometry is. By definition, hopefully in grade 10 you learned these words called sine, cosine, tangent. Okay. And we usually use the trigonometric operation of an angle, and I'm going to use this symbol. Hopefully you've seen this before. If you don't know, this is theta. That's how you say it. It's the Greek letter TH. We tend to use Greek letters for angles. We can sometimes use X's or Y's or even the angle A. Right? So I'm just going to use this in generic terms. The sine of theta is equal to the ratio of the opposite side over the hypotenuse. So even though we have a right angle triangle over there, let's label this triangle. In this example, I am going to circle angle A. And so in this example, the short form for sine, S-I-N-E, is S-I-N. Even though it spells the word sin, please do never say sin to me. This is still pronounced as sine. I understand it's seen for Mr. Chen. We still say sine. Just like this, we don't say Thu, Oct, 15, 2000. I think everyone agrees. This is Thursday, October 15, 2020. Okay? So even though we use short forms, we still say the full name. That's why sometimes this is kind of good that I actually left the date on our chalkboard. So the sine of angle A, we look at our triangle and we name our side. Any volunteer from the class here? Because this is our reference point. Can anyone tell me what's the name of side C? How much you know this one's really easy from grades 7 and 8? Really easy. Can we name that side? Noah? It is the hypotenuse. By definition, what you learned from grade 7 or 8, even grade 9, I think. The hypotenuse is the longest side for a right angle triangle. It's also opposite of the largest angle, which is 90 degrees. Then I'm going to actually name these two sides with respect to this angle now. I know I have to finish it, but we're almost there. Ryan?
B is adjacent, A is opposite.
Nicely done. So A is the opposite to that angle, and B is the adjacent or next to it. So in this example, by definition, sine theta is equal to opposite or hypotenuse. We actually have some letters. And in this example, I think everyone agrees, but I'll just do this one. The opposite is A and over C. It is a ratio of these two sides. And notice there aren't any numbers, right? But eventually we're going to take a look at those numbers. I don't know what the angle is, who cares? Because a lot of you realize there's an infinite number of triangles that we can kind of draw. And that is sine, right? Moving right along, cosine of theta. Cosine, and we'll talk more about the history if you really want to know. It's actually related to the CO, co, but mathematically, these terms, sine and cosine, they were a mistranslation of the algebraic word of a curve. So it's just a mistranslation. So we could have called some other things. And it's actually neat if you really want to learn more. But these words were designed solely only for trigonometry. There is no other mathematical connection with that. In any case, cosine of theta, definition is adjacent over hypotenuse. And so the short form for cosine is COS. And I still like saying cosine, but a lot of students nowadays, they just say cos. Or if you're in the UK, they say cos, which is also fine. So cos, cos. But please say sine. Don't say sin here. No. Terrible. Don't say that. It's cosine. You see someone actually can do it now. Notice that the triangle has been already labeled. And you don't have to always do this. A lot of you innately, eventually, with practice, will do it. Owen, please, if you don't mind.
B over C.
B over C is correct. And finally, tangent. You've actually seen this, you just don't realize it. You've been seeing this ever since grade 9. Tangent is equal to opposite over adjacent. That's my son. You didn't get that on video. So tangent is short form TAN. That's why on your calculators we have those 3 buttons: sine, cosine, and tangent. Tangent of A, volunteer with this triangle. Please give us the ratio. Kadina?
A over B.
A over B is correct. And notice it's easy, right? Okay. What's interesting is that we can definitely change this up. And so there's a mnemonic that a lot of you already know. And it's SOHCAHTOA, where sine is the opposite of our hypotenuse, cosine is the adjacent of our hypotenuse, and tangent is the opposite of our adjacent. So as an extension, let's just see if you guys can do it. I'm going to redraw a triangle. And you don't have to copy this if you don't want to. We'll just do it to make sure we're understanding. We'll call that P, Q, and R. And I'm going to ask you 3 questions. Hopefully you guys can do it. Please give me the ratio of the sine Q. Please give me the ratio of cosine P. Please give me the tangent of Q. Take your time, we'll take 10 seconds. You will pause the video. So, ladies and gentlemen, you're just rejoining us back from the video as I pause the video for recording. Those are the answers that we had that I made up. So hopefully you guys can follow along and see the questions. Alright? It's important to actually know how to label and name the sides. So you might need practice in reorienting yourself with the triangle. Notice again, we tend to not do any sines or cosines of 90 degrees. Now technically, eventually we will, but at this stage in grade, let's say grade 10 or beginning grade 11, we never really did the sine cosine of 90 degrees. We do, but we can't do it in this context in this way. Okay. So example 1, really, really easy. We're going to practice now using our calculator. Actually, you know what? Sorry, let's go back a step, ladies and gentlemen. Sorry, I'm jumping the gun. Some already know that I've been saying a ratio of sides. And by definition for ratio, like if we say a ratio of 1 to 2 girls, so 1 boy to 2 girls, 2 girls to 1 boy, the ratios should stay the same because the units are the same. So some students are probably wondering in trigonometry, why are these the definitions for these ratios? Why can't we have, for example, for sine, why can't we have the hypotenuse over opposite? So if you take a look at your handout, it says reciprocal trig ratios. That's actually what we're going to try to teach you beside you. And so if we flip this ratio, and sorry, I just use a short form, is that okay? This will save my hand. Unfortunately, it's not called sine. So for grade 11, this is called cosecant of theta. And the short form for cosecant, we can't take the first 3 letters because cosine was already taken for cos. So this is known as CSC. So the way that you pronounce this, ladies and gentlemen, it's called cosecant. Now, a lot of you are already looking at your calculators. Mr. Chen, we don't seem to see that button there. So technically, these ones are called the primary trig ratios. And these ones are called the secondary. And we'll explain how to actually calculate this, hopefully later in this period. If not, hopefully eventually tomorrow. Moving right along, notice again, if we take the reciprocal, or flip this ratio, the hypotenuse over the adjacent, this is actually known as secant. And the short form for secant is the first two letters, SEC. Okay, and finally, if we flip the tangent ratio of opposite over adjacent, so it's adjacent over the opposite, it's called cotangent. And the short form of that is CO2. So although you learned, and I already erased it, so let's just go back a step. You learned SOHCAHTOA for the primary trig ratios. There is no mnemonic for this one. Technically, I made this one up. Although, if you take the first two letters, Cho, Sha, Cow. It's not official, but that might help. So it's all related to just the reciprocal. Okay, so those are the values for that. And again, really quickly, just draw a triangle. A, B, C, and that's C, and that's A, and that's B. So just to show you, for sine of angle B, so it would be B over C. And if I were to ask you this, what's the secant of angle B? By definition, secant of B is the hypotenuse over the adjacent. So that's our angle. So secant hypotenuse, that's still C over A. Did I do that right? Yeah, I think I did right. Everyone okay with that? So these are the new ratios that we're going to look at. Any questions from the class? Okay. Don't worry, I will show you how to evaluate that in a moment. Okay, so let's just go to the example here. So, example number 1. How to use your calculator? Set your calculator in degree mode. And notice it says evaluate cosine of 60 degrees. So we're not going to draw a diagram, we're going to do some calculations. And in the olden days, before they had calculators such as this, seriously olden days, like in the early 1900s, there would be a massive book of all these ratios to maybe 4 or 5 decimal places only. So if you do cosine of 60 degrees, just enter this exactly how you see it, and you press enter. So your calculator is called direct algebraic. Whatever you see, you can just enter in. You have to be careful what I just said there, because there's some instances that it's different. And the answer for this is 0.5. Everyone agree? Hopefully everyone got the same answer. Now some students want to know what this really means. Well, I think you can change this decimal to a fraction, and that's 1/2. So to make it a bit more clear to help everyone else understand what these things represent, if you draw a triangle, just a triangle, it doesn't have to be super accurate. And I like putting my angle in this corner here, so let's say this is 60 degrees. Cosine, by definition, is the adjacent, and I forgot what color it is. I think the middle, or the hypotenuse. So, in essence, you could create your own right angle triangle. And this might be a useful tool. Most students don't do this, but in the future, this might be a solidifying or understanding concept of what you could do. I'll explain. It's very helpful. So the 1 will go here, and the 2 would go here. Before we continue, everyone okay? And do you think you could tell me what this opposite side would be? Notice I am using the word opposite because this is 60 degrees, and this is the opposite, is not. Do you think you could figure this out? at this stage, let's pretend from grade 9, don't get me wrong, we could do some trigonometry, but I just want to make sure. Tanash? Yeah, the Pythagorean Theorem, right? A lot of you already know the Pythagorean Theorem. Is the hypotenuse squared is equal to the squaring of a squared plus b squared, right? That's the Pythagorean. And again, it's only worked for this one, right? For a right angle triangle. So let's see if we can actually do it. Can you all want to actually try to tell me what is the exact answer for this side? Take your time. Exact answer. I didn't say approximate, I said exact. Tanush? Square root of 3 is correct. So even though this is a derived answer, and we'll talk more about this later, this is actually what's called a special triangle, or a Hall of Famer triangle, to quote Mr. Petal. Some students eventually memorize this, but for now, if you had to do the Pythagorean theorem, you should be able to do it. You need to prove 2 squared is equal to 1 squared plus, let's call this y squared, 4 is equal to 1 plus y squared. Subtract 1 to both sides, you get 3 is equal to y squared. And y is equal to square root of 3. Notice we can't take the negative answer, even though it is the solution. The negative answer does not make sense with this length. Don't forget, we'll talk about the negatives later. Example B. Find the value of theta if cos theta equals 0.5. So notice this is the inverse, not reciprocal, inverse. So for example B, you're given it this way. So in this context, you're trying to isolate for the unknown. And so what you're supposed to do to both sides is the opposite operation. Well, the opposite operation is what's called the inverse. And this is why the way that you're supposed to solve this, whatever you do to one side, you have to do the other side. So you're going to do the inverse cosine operation of that ratio. And when you use your calculator, this is what you're going to probably push. I apologize, I should be using orange because I think it is orange on the calculator. You're going to do the second function of the cosine because above it is that cosine to the negative 1. And that cosine to negative 1, a lot of you already know, it is the inverse operation. So you push this, and this is exactly what you see in your display, assuming that you're working in degrees, and you should get the answer 60. But if we're working in degrees, this actually has a unit, 60 degrees. Question C is kind of unfair because normally I do not like having angles that are greater than 300 or greater than 90. But is there a volunteer that would like to give me the answer for cosine of 300 degrees? Tanesh?
I think it's also 102.
It's also what?
I think it's also 102.
I'm not sure. Well, I need somebody to use a calculator. You need a calculator. Anybody? Right? It is also 1 over 2. 0.5 and 1 over 2. And I think this is the reason why they're putting this question here, even though I don't like it. What's weird about your calculator, ladies and gentlemen, this is what you should be suspicious. If we were to do the reverse, the inverse of 0.5, how come we're getting this same answer, 360 degrees for this? But the ratio, or 0.5, it's not getting out with it. If we do the inverse of this, how come the calculator's not giving us 300? Why is it only giving us a 60 degrees? And it has to do with the circle, which eventually we'll get to. So this is just something to cover your heads about. Honestly, if you are concerned about like, how can I draw that with the right angle? Like I can't with the Chen 300 degrees is something like that. What the hell are you talking about, Chen? Right? I can't draw a triangle from this end, does it? Because by definition, what I already know is that the sum of the interior angles what's equal to 180. And in this example, it seems to fail that problem. But some of you are still kind of seeing what I'm doing, because some of you can see maybe a triangle. Maybe not this direction, but maybe like this. And there's our triangle. In fact, some of you can kind of see it. Now, I don't want to do it yet because it's in the future. Okay, so we'll talk more about that in a moment. Any questions about example 1 and finding an angle or evaluating a trig operation? Any question about that? Okay. So example 2, I think I don't need to do that one. I think you guys can actually do it yourself. To solve a triangle means to find all the unknown sides and angles. Okay, well, let's just do it. Maybe we should just do it. I'm going slower than I thought. Because I can't tell from your faces, and since you guys don't say anything, you only internationalists. Let's just do it. Any volunteer have an idea what we can do first? Can you?
The first is like AC equals 6.
AC equals 6, yeah. Side, okay, so that's another way. So AC, nice done line segment, AC, it's equivalent to saying side B, right? So, anyways, that answer is 6. Nice and done. Does anyone actually know this means pattern? Tadashi again. It's basically another kind of, not the Hall of Fame triangle, but it is a touch triangle. Here's a triangle with this. Oops, and draw it wrong. It's a Pythagorean triple. That's what they call it. And it's a nice number, 3, 4, 5. And it's just, hopefully some of you remember from grade 10. It's a similar triangle. 3, 4, 5. It's 6, 8, 10. It's just the ratio is increased, right? Hopefully you guys remember from grade 10. But now that we have all 3 sides, thank you, Padina. Can we find actually angles? How can I find angle B? Any volunteer? You have actually now so many different ways to solve it. Just one way to do it. How can I find angle B? Arita?
We can use the inverse function of sine.
Sure, so let's just set it up. Okay, so sine of B is equal to
6 over 10.
6 over 10, which really is 3 over 5, right?
Yeah.
And then you said inverse sine of 3 over 5. Let's get this to 1 decimal place. Is that okay? What's angle B? Is that okay? Reduce our fraction, 3 over 5? Which is 0.6, right? Padina?
It says 36.86.
86? So let's just round to 1 decimal place, 36.
7.
Yeah. We'll do 36.9, is that okay? 1 decimal place, is that okay? Just for argument's sake, just so that we're keeping it consistent. You would obviously read the question on the test. If it's set to 2 decimal places or 3 decimal places. How can I find angle A now? Padina again?
Do the same thing you did for B and also for A. So like the inverse sine of 4 over 5.
Now don't get me wrong, this is clearly good. There's also a grade 9 way. Arita?
We can use the interior angle theorem. So 90 plus 36.9 and we call it angle A is equal to 180.
So 36.9 plus, what did I get? 180 minus 2. Oh, that's it. So angle A is, of course, and you should get the same answer, you know? Right? Sorry. What did you say? 53.1 degrees? Thank you. And they should be the same. Everybody agree? Nice. Deductive reasoning from, technically you're using what's called a complement, right? Because or you said it right, interior sum of triangle, but the reason why I said complement, just let everyone know, is because If this is 90 degrees, the sum of these two angles is also 90, right? And that 90 is actually complementary. And if you really want to know why it's called sine and cosine, it's because they were complements. So that's why in our previous example, the P and the Q arc triangle, when I gave that sine and cosine question for, I think, angle P and angle Q, I think, you get the same ratio. Because they're complements of each other. Example 3, I think this is, holy cow, I'm not even getting to the hard questions. Example 3 is straightforward. How am I doing now? This video is going longer than I thought, but that's okay. Example 3, it says if tan theta is equal to 5 over 12, find the other two primary trig ratios. So they did a sketch for you already. I don't know why this handout is like this. I like drawing always my triangles. You'll know why later, but for now, I like doing my triangles like this. You'll see why. So I apologize if it seems to be disorienting you from your answers, but this shouldn't matter. But I can only teach it this way. Do you think you can find the other two trig ratios? Exactly. Do you think you can tell me the other two trig ratios for sine and cosine? Notice it's not asking you for the actual angle, right? See, so none of the connections really doing. He's like solving the unknown sine, which is what we wrote in red, the Pythagorean Theorem. And this actually is a neat one. That actually happens to be 13. So then he's just now using the relationship of sine and cosine, right? So this would be 5 over 13, which is the opposite of our hypotenuse, and cosine would be 12 over 13. As an enrichment though, do you think you guys could continue this to give me cosecant, secant, and cotangent? You know, so I'm not asking for the ratios. Do you think you can just do it just like that, really quickly? Maruna, do you think you can do it?
Yeah, cosecant is 13 over 5. And secant is 13 over 12. And cotangent is 12 over 5.
Which in my opinion is actually the easiest one, right? Want to see this? So some of you are realizing a lot of like exact answers are fractions, and this is actually why. Decimals kind of suck. Decimals really suck. It ruins us, and that's why you can tell almost with the fractions, you can almost attribute, and I apologize, you can almost attribute the sides and their angles with those ratios. Before we continue, any questions about this? Before we talk about some straightforward grade 10 questions. So I think the last example we're going to do is example 4. Notice, I think you guys can figure these out yourself, but just to make sure we're careful and everything. In this introductory lesson of trigonometry, it's some good practice. And I think this is where we're going to do it. So let's just recopy the example. Example 4 says, a guide wire 20 meters long supports a tower and forms an angle 57 degrees with the ground. And they gave you the diagram. Now in grade 10, these are fair questions because given the diagram, you should have no problem. But in grade 11, we tend not to give you the diagrams. So it's usually some kind of inference or making sure we're clear with this. So with our diagram here, this is our tower. And the guide wire is that length there, right? So this is 20 meter. Yeah, 20 meters. And this is 57 degrees. Ground over here. So notice I made a right angle triangle. And it's asking for question A. At what height to the nearest meter is the guide wire attached to the tower? Now, for some of you, and I think a lot of you, for this class, definitely you're stronger with our ratios. You can set this up, right? We're trying to find this, right? For question A. So we can call this h if you want. And we're trying to solve. So with our mnemonic of SOHCAHTOA, we tend to use the primary trig ratios only. Don't get me wrong, we'll talk about the secondary ones maybe online tomorrow. How can I set this one up? Any volunteer? Would I use sine, cosine, or tangent to solve? Notice we have only one side, but we have an angle. Any volunteer? Ted, what's that?
Sine 57 is equal to x over 10.
I'll use h, is that okay?
Oh,
And the reason why, thank you, Ted. The reason why Ted's using sine is because this unknown is the opposite side. And this is the hypotenuse. And using the mnemonic, which one has opposite and hypotenuse? Well, not this one, that one has opposite. Not this one, the one has hypotenuse. This one, or sine, has opposite or hypotenuse. Before we continue, everyone okay? But how do you actually use this equation then? This is actually the reason why we use trigonometry. Unlike the warm-up questions that we were doing examples 1, 2, and 3. Those ones are when you have a triangle and just doing some relationships. This is actually how you find the heights of objects that are far, far away apart. In fact, with engineering and surveyors, this is what they do. They get a tripod, they have a clinometer, they find the angles, they already know the height of the stadia rod, and then they know the distance away, or they measure the angle, then they can find the height of the object. In this case, we were given this guy wire, 20 meters, right? And so I think a lot of you already know how to rearrange equations. We're trying to isolate for the h or the x, in this case h. Divided by 20, h is equal to 20 times the sine of 57 degrees. Now, as an aside, some of you, that's not a decimal, it's a multiplication. Technically, this is also true. Well, watch what I can do, please don't copy this down. Technically, you could have written like this. But this in orange, please don't write this down in orange. It's because when you write it like this, although mathematically it should be fine, you would agree, multiplication is commutative. The calculator will assume you're doing the 57 degrees times 20, which is incorrect, right? So I must warn you, that's why we almost always kind of like write whatever value here is in front. It just seems to be stylistic. Granted, in mathematics, multiplication is commutative, meaning 3 times 4 is the same thing as 4 times 3. It shouldn't be a problem here, but for some reason in trigonometry, I just want to make sure you're getting the right answer, ladies and gentlemen. Don't ever write it this way, okay? So can I get a volunteer? Again, make sure your calculator is in degrees. Most students will just simply write in 20 times the sine of 57 degrees to 1 decimal place. Can I get a volunteer to tell us the height of the tower? This is now, notice this unit is just punching in your calculator. Fadina again, thank you. 16.8. 8? Can I get a second volunteer to confirm that?
Yeah.
Thanks, Ryan. Or okay. Question B though. How far from the base of the tower is the guy wire attached to the tower? So a lot of you already know for this one. We're trying to solve for B. I'll call it B there. How far from the base of the tower is the guy wire attached to the tower? Different volunteer. Notice Ted solved this using sine for question A. For question B, different volunteer. How would I solve this? Right?
Cos of 57 is equal to 20.
Cosine of 57 degrees is equal to b over 20. And don't get me wrong, thank you very much. Technically, we could definitely use Padina's answer, 16.8, to approximately find that. But I like how you're thinking of it, Ryan, and the rest of the class. It should be fine, right? We could definitely use the Pythagorean Theorem with that 20 and that 16.8. But let's just use some trigonometry, right? So it's almost exactly the same. Thanks, Ryan. 20 times the cosine of 57 degrees. And I encourage you to check to see if you could use the Pythagorean Theorem. But of course, it'd be a decimal answer. And again, can I get a volunteer to give us the base? Owen?
10.9 meters.
10.9 meters. Can I get a second volunteer to confirm that? It seems about right. Okay, so we only did the first 4 examples. Examples 5 and 5, I think you should be able to do. It's actually interesting. The last part of example 6, I just got to make sure we're clear. Let's just move this over here. I'll erase this. To finish off my lesson, I'm reviewing this. And again, I noticed I didn't do any of the cosecant, secant, or cotangent. We'll obviously maybe do that online as supplementary. The only thing for example 6, and it's actually written there, is some terminology. If we look along the horizontal, either from left to right or from right to left. This is called the angle of elevation. Some people call it angle of inclination, but that's what that means. So the angle of elevation. Conversely, if we go along the horizontal from left to right and drop down, or from right to left and drop down in red, this is called the angle of depression or declination. Okay, so some people always want to know what do you mean, what's an angle of elevation, angle of depression. So if I do my hands like this, and go like that, go upwards, this angle is called the angle of elevation. Okay? So for some of you, we're looking at example 6. And again, the diagram is already given to you, so a lot of you already know that, but in grade 11, when we don't have the diagram, it tends to be relatively challenging. Okay?